Assalamu alaikum everyone. Welcome to my channel Care Corners. First of all, I would like to recite uh, Bismillahir Rahmanir Rahim. So I'm going to start. Today's lesson is Spearman's rank correlation coefficient. It's generated by RS. So we can say in short. Rank correlation. So see what's the rank correlation coefficient, Spearman rank correlation coefficients. Um, First, by the way, so what is a correlation first? Correlation, first we need to know is correlation. Correlation is a statistical technique used to determine the degree to which two variables are related. It means, both variables, x and y, how much these variables are related to each other. And there's any relation between x and y. Actually, we are looking for through computation. So that both variables are correlated each other, independent. So if both are independent, it means no variance. So covariance zero. So Spearman rank correlation coefficient. Okay. So it is a non-parametric measure of correlation. This procedure makes use of the two sets of ranks. It may be assigned to the sample values of x and y. If you don't have a rank, so you need to rank them, rank them to x and y. Okay, later on you see the Spearman rank correlation coefficient could be computed in the following cases. Both variables are quantitative, x and y variables are quantitative, means 1, 2, 3, 4 is a number. So and both variables are qualitative ordinals. What is qualitative ordinal? So qualitative ordinal means like a half quantitative, So like I'm giving grading, so to students, so to my students, first, second, third. What does it mean? So it's kind of quantitative, This is a qualitative ordinal. Okay, first grade, second grade, third grade. Okay, and one variable is quantity, another is quality ordinal. So could be so. Procedures for correlation, rank. So Spearman coefficient. So Spearman's correlation coefficient. Okay, so it's up to you. What do you call it? Like correlation, rank correlation. It's okay. Okay. In short, we say rank correlation. So, okay, procedure for rank correlation. So rank the values of x. First, rank the values of x from 1 to n. It depends on where n is the number of pairs of values of x and y in the sample. So you see check observations table. So how many x are right in the table. So it should be equal x and y, right? So that then you can compare, right? So next step is rank the values of y. Similarly, from 1 to n, and compute the values of di in a difference, for each pair of observation by subtracting the rank of y I from the rank of xi, means xi minus yi. So there's a difference, right? So number 4 step is square each di. This di, what you have got, di is xi minus y, and then you square, and then sum up d square sums, which is the sum of di summation di square, means which is the sum of the squared values, means di square summation di square means sum of the squared values. Okay, so a formula for Spearman rank correlation, or rank correlation, simply formula for that. So RS is rank correlation coefficient is equal to 1 minus 6 times summation di square divided by n times n square minus 1. So n is the number of observation, gi is a difference like of ranks x and y. So and okay, there no other constraint right here. So very simple, right? With gi and n, two parameters. Okay, here the values of RS denotes the magnitude and nature of association, giving the same interpretation as simple R. You have seen a lot of times, while preparing graphs through X origin for or XYZ software, so even R software. So you see R, actually you see the your data, your observation are and your trend line. So you see deviation actually, and through coefficient correlation, you can rely, you can see your data is very deviated from the trend line or not, is very strongly related to your trend line, and your trend line is really fitted with your according to your observation table. So it's just all about relation. So you're looking yeah, how your data is fitted. So your trend line is fitted perfectly or not. So okay, it's through a correlation, so you can define. So anyway, just today, so just we see rank correlation, not correlations, rank correlation. So see a question here: eight computers in a Y says are ranked by two judges in the following order. So computer, how many computers? Eight computers, A, B, C, D to H. So and ranking by judge one. So judge one gives five. It's like a five rank two for this computer, and judge two. For this computer, rank for rank this computer. This judge. You know, four is like this judge giving four rank to this computer, right? It means so. Okay. Similarly here, so we are checking here, looking here, and judges are really giving marks, giving like points to computers. Your ranks, giving ranks to these computers are fairly or not. So anyway, so that's why we are looking actually. That's why we're looking at coefficient correlation. So yeah, or here is rank actually we are giving ranks, so that's why we say rank correlation. So find RS between ranking of two variables, so X and Y. So first we do make columns of 1, 2, 3, 4. Into four columns we draw, and first in columns, first rank X, the second column we put rank Y, and third in third column DI. This is the difference X minus Y, and DI square means square of this difference. So these are ranks. So you see here, you see 5, 4, 2, 5. You see here 5, 4, 2, 5. Similarly here 7, 6. Okay. So 5 minus 4 is 1, 2 minus 5 is minus 3, 8 minus 7 is 1, 7 minus 6 is 1, and then square root of 1 is 1, square root of minus 3 is 9. Similarly, square root of 1 is 1, and then we sum up these values, and then we got 28. So then we put up here, so RS is equal to 1 minus 6 times summation DI square. Summation DI square is 28. So we put up here, and n times n minus 1, n times n square minus 1, and is here's 8 observations. So 8, that's why n is equal to 8 we put up. So 8 square is 64, and then see 0.67. So what do you think? So a correlation, your rank correlation between two judges, so is fairly or it's a relation between X and Y is good or not. So what do you say? I think it's a good relation, because 0.67 means like around 70%. So I think both judges are giving fair rankings. So sometimes judges are sometimes maybe can be they maybe corrupt. Maybe sometimes you find sometimes judges giving rank not fairly. So that's why we're looking at two judges are giving are honest or not actually. Sometimes bribery is very common, so that's why we're checking judges are giving marks, ranks. It's not biasly, just we are looking actually. So now is there fairly marking, so giving actually ranks here actually is how we say marking. I think it's a good relationship, my opinion. So okay, it's your homework. So here, so 8 students here, and you see relation between two, here variables x and y. So this student A and got he has got marks 83 in mathematics and 94 in physics. Similarly, and you see the relation, these two variables x and y, actually mathematics and physics. So students are getting marks in maths and physics, or students studying very hard in both subjects. So you can see through correlation, see students are really hardworking and both subjects. Not just mathematics teacher is good, physics teacher not good. So you can see their marks, student marks. So we can check it out. So now first you need to give them rank. So this is student, so 83. So you see, but first you check it highest mark. So E is, here is supposed to get rank, supposed to, I have to give rank to this student 1, and 82 second highest, second rank, 73 third. The between 92 90 100 marks rank 1, and who qualify 82 90 marks, so 80 90 marks, 82 89 marks. So who qualify this mark, so you're giving rank 2. Similarly, between 70 to 79, so you can rank 3. See here, G, uh, you know if you are giving rank to this student, so you give 3, and for C student, so you can rank 3. So it's up to you. So you can rank, and you like first you do like this way. So rank them, okay, and then make 4 columns. So and then find di square, and then plug in this formula. Okay, and then here n is 8 8. You see here 1 2 3 4 5 6 7 8. So you check it out and comment me, and then I hope you will complete this homework at home, at your home. Hope so. And please respond to me soon, in 2 3 days, and I want to see your answer, and I want to know you are following me or not. Okay, thank you for watching. Bye bye for now.